This is episode number 27 of Colorado TechCast. Hey everybody, Trapper here. Thanks for joining me on this episode of Colorado TechCast. Colorado TechCast is a weekly podcast where I interview CEOs and founders of Colorado-based technology startups. Join me each episode as I explore the Colorado technology community from the inside out. Today in Colorado TechCast, I'm joined by Grant Flaharty, President of Aleph Objects. Grant, thanks for joining me on the show today.
Thank you for having me. We're excited, the entire company is excited about being on your show today. So again, thank you.
So Grant, tell me about Aleph Objects. What do you guys do?
So what we do is we actually design, develop, and manufacture 3D printers. And we're just a little bit different than most of the 3D printing companies out there. Let me explain that. There's two gentlemen who really have, founded the company and did the initial great expansion of that company. And it's Jeff Moe and Stephen Abedy. And what they did was they founded the company on a single premise, and that was to have free software and open hardware and open sourcing. Now let me just explain why they would want to do something like that and what the benefits really are. Why is because the founder, Jeff, has been a Linux based guy from the very beginning, and has said all along in his mind this was really the route to go, and to get more people involved and to open it up for everything. To take it into this printer mode and say, hey, we're going to found a company and we're going to utilize only free software and open sourcing and open hardware, allows the company to actually, and I'm going to say two different things. One is it allows the company to expand its R&D force to several thousand people out there instead of just what you would actually pay for internally for R&D. Because what happens here is we put everything out and we let everybody know what we're working on, and there's a tremendous amount of tinkerers, companies where people are using this, engineers inside of bigger companies that are using it, and they take and they modify different things on it. Modify the software to handle this, modify nozzles to do this, to put in different filaments, materials, whatever it is out there, and they get that particular thing working, and they feed this back, or they ask for us to make a change to this, and they can do it. So what it does is it opens up initially a tremendous amount of additional resource, and you get market feedback immediately with all of these different things. So the marketing side of the house has also a giant marketing machine behind it when you utilize all of these people who are actually using this stuff and feeding these things back. I want to give you just one example to really drive this home, and that is at Michigan Institute of Technology. There's a gentleman there, Joshua Pierce, and he has 41 of our printers, and they're working on it all the time. And one of the things that he's doing with his students was saying, hey, there's two areas of printing end use. One is prototyping, and you want to do the rapid prototyping so you get things to market quicker. And the other is the additive manufacturing side of it. And that's where you're building parts and you're using the 3D printer to make parts, and I'll get into that a little more in a bit. But what he has done is he said, hey, from the additive manufacturing standpoint, one of the things you need is constant feedback. So he's gone in there and he's actually using his printers, making these parts, and he's looked at the slicing code itself, because what happens is you take a model and you slice the model and you build it layer by layer up. So he's looking at the slicing code and saying, hey, this is what it should be doing. And then he's using cameras with code in the cameras and saying, hey, this is exactly what is being built, and is there a difference or not? And if there is, that feeds directly back in, so then you can either have an iterative approach to your slice, or you can send out direct alerts to people saying, hey, this is being manufactured, but you have a problem. And the problem could be like the filament is a little too thick in one spot or something like this, right? So it could be very simplistic. It could be very complicated. But this allows now them to go through and come up with this, and it gives the students and everybody an opportunity to change what's going to happen in the future. Now, that particular little piece right there, I just got the white paper, went through that whole thing, and I'm taking a look at it and going, wow, we need to implement this, right? So that's just a case in point of opening up your whole R&D side to allow this to happen through the use of free software, open sourcing, and open hardware, right?
You're basically scaling your entire workforce horizontally and distributing it out to the world.
Yes, you are. And I'm telling you, there is another player in the market, in Czechoslovakia doing this, but outside of that, this is, and always has been, a market that is heavily patented. And so this allows more people to be involved in that and really to exponentially move this market forward, right?
This is on the lull spot that prints out, is it plastic-based or is it like a polyester-based filament?
So actually it is a plastic-based filament, but you actually have true materials in every different type of thing. Polypropylenes, ABS. We're running right now different carbon fibers mixed with plastics, bamboo mixed with plastics, all these different types of things, and those are mixed with nylons. But I mean, it's open to just about anything that you could make a filament out of. And using filament is just nothing more than extruding out into a small, it's extruding plastic into a small line instead of into pellets and stuff like that, or into pipe or whatever you want to do. And so you just get reels of this material, and it's true material. It's true ABS, it's true polypropylene. There's just different, varieties of it, right? And I mean, everything under the sun, and we can get into a little more what I was going to get to in a little bit, but some of these filaments, and I will give you a good example, direct use of this to do direct implantables. And so there's actually calcium-based filaments out there so that you can actually go through and print bones and put them in. Now, obviously, inside of the United States, that's still, a bit of an issue to go through from the FDA perspective. But that is where it's going, and that's where it's going to happen. And so there's entire biodegradable filaments that are out there. And since we brought that up, I don't know if you saw or not, but last night on CBS News was a great example of this. And at the end of the CBS News last night, they talked about a little dachshund named Patches that had a tumor on the top of its head. And the owner had gone and wanted to get this fixed. And so it went back and forth, and like, wow, we're going to have to take 70% of the skull off to do this. So they scanned the dog's head. Cornell University scanned the dog's head and printed out a new 70% of the top bone structure, made it in titanium. So they went ahead and did the surgery, took out the tumor, implanted a 70% of the entire top of the skull out of titanium in there. And Cornell uses our equipment.
What? A skull for a dog out of titanium?
Yes. Anyway, take a look at if you get a chance, take a look at CBS News last night. And it was on there, and the entire nation got to see it, and just an exciting little thing. But it gives you the glimpse into the future of what this is really going to do and be, right? The sky is unlimited with this type of technology. And obviously they use this stuff in NASA, and they use this stuff for orbital sciences. Everybody uses it, so.
This just isn't like the MakerBot for hobbyists anymore. It's true production value.
No, it's not. So since you brought that up, the true production value, as I said, there's two different areas of this, but I'm gonna digress just a bit. And that is inside of Colorado, and obviously this is a Colorado podcast and based upon Colorado entrepreneurs. And most people don't know this, but this entire technology was actually started by a Grand Junction, Colorado native, Chuck Hull. Hull. He started this entire industry. He was working at DuPont, and then he took that technology out from DuPont. And he started the entire industry, and he started 3D Systems. And 3D Systems, was the first, and they were using stereolithography, using lasers against photocurable resins to make rapid prototypes. And when I started with 3D Systems, I worked with Chuck for about 7 years, and it was just an amazing, amazing time. But when you look at it and you say, hey, there's two different things that are going on with this, and one is the prototyping side and the additive manufacturing. Inside of Colorado, and Colorado is our largest market, inside of Colorado, we're a preferred supplier for Denver Public Schools and also in the libraries. And so when you take a look at it, you say, hey, now all these kids are using these. There's so many different STEM setups that have our equipment in it, and they're using it, and they're making prototypes of every different little thing and printing out just little toys, print out everything. And you can go to libraries now, and you can get on, and you can do this, right? It's evolving so quickly. And if I take the prototyping side of the business, which for us is still the largest market for us right now, but we are rapidly moving into utilization of this equipment in additive manufacturing. And we have we get nominated, and we just got an award last week from 3DP as the workhorse printer of the industry. And I mean, this stuff is virtually indestructible. And in fact, you can see videos of us putting these printers and turn them on, printing parts, and putting them on bungee cords and bouncing it up and down, and it doesn't affect the part. We actually have a guy inside the house named Greg Barkley who actually goes out there, and he's a rock crawler, Jeep guy, and he's got one of these installed on the back of the Jeep, and he's bouncing over everything, and it's still printing. Anyway, it's just kind of some neat stuff.
A printer on the back of his Jeep?
Right. Just, showing that you can do anything with it.
So I guess if anybody, guy out off-roading in a Jeep, is probably more likely to need to be able to create a part out in the middle of nowhere than anybody else. So good test for it.
Right. That is a good test. So let me just explain. So on the additive manufacturing side, we actually utilize, and we have a cluster inside our manufacturing facility, and this is very interesting, and we actually utilize our equipment to make parts to go into our equipment. Now, on the two main products that we're selling today, on the bigger product, 60% of all the sub-assemblies have piece parts made on our own equipment. And on the small little mini one, up to 50% of the sub-assemblies have parts made inside our own little cluster on our own equipment that go back into the equipment.
So this is a self-replicating machine, like Skynet.
So like Skynet. And one of the really interesting things is because you use it for that, you can understand you have to have this working 24/7, and so the quality of the equipment is improved because we have to rely upon it ourselves. And I will tell you this, in the year 2019, with our current production schedules, we'll make more than 1 million parts for our own equipment in the year of 2019.
So your machines are actually making parts that go into the supply chain?
Yes, we'll make 1 million parts in that 1 year. Now it takes about 14 months to do 1 million, but in 2019 we'll make 1 million in that 1 year on our own equipment.
Exponential growth is as you build more machines, those machines can build more machines and just scale up from there. That's really great. Using the open source collaboration, you guys have opened up this to the world, basically. How is the company structured? Are you in business to produce the machines? Are you in business to evangelize and license patents out of this? Or tell me more about how the company operates.
We do not patent anything, and it is open. And that is the true nature of open, is it is open. There is no patents. We don't charge licenses. We don't do that. And so it's open for a reason, and it's for us to continue to work with the community to make everything better, right? And so by doing that, people will say, well, gosh, you've opened up everything so people can see whatever you're doing. Like, just our assembly instructions, they're online. Anybody can see them. But what it does is it does a couple of things. Number one, like I said in the beginning, it extends, and as you mentioned, horizontally extends our R&D tremendously and our marketing. But one of the other things it does is it forces you to execute faster than your competition in all regards, because they can see what we're doing too, all the way down to, like I said, our assembly instructions.
There's no competitive advantage there?
No, it is open. And there's hardly anybody in business who will actually understand why you're doing this. But when you start to see how the quality of this equipment, and that's the reason for it, is it's instant feedback all the time. And if you made this change, you made this, it would do this, it would do this. And it's very, and like I said, it pushes you into a competitive mode that most people never will be in, and to have to execute all the time better than your competition and to be out there in front of it, So it's interesting. It's a different approach. And when we take a look at the exponential growth that we're on and are going to be on, 10x over the next few years, there's a tremendous amount of directions that we're going with this, and both in additive manufacturing and in the prototyping. And when I lump the prototyping, I think about all the different things like, jewelry and hearing aids and all the dental labs and stuff. Some of them are currently using this technology, others aren't. But all of this will be directly implantable, directly put into your mouth, out of the equipment. All of this stuff is the directions that we're going, and we'll have help in every one of those, because the people who are using the equipment want it to be best for their particular market niche.
It's a really exciting future to definitely be in.
It is. It's like I said, it's so totally different than most business models.
So tell me more about the company. Like, when were they founded? Just the history.
Yeah, the company was founded in 2011. And as I told you in the beginning, it was two individuals, Jeff Moe and Stephen Abedy, and they've been here from the beginning. And it's based in Loveland, Colorado, and just right on the edge of Fort Collins. There's two different facilities. One houses all the administrative type of things, sales, marketing, finance, and the other houses all of the manufacturing side of it. And the reason there's two buildings is just growing so fast. And there's tens of thousands of these units out in the marketplace today on throughout Europe, United States. United States is still the biggest marketplace, and also inside of Asia. But the movement of this will be globally. How are we going to expand the global market so quickly? And this stuff, it's amazing when you look at it. The stuff sells on Amazon, right? You can get on Amazon, you can buy these printers. You can buy them through resellers, you can buy them through direct online from us. The marketplace has changed phenomenally, since the early 2000s for this type of stuff. And obviously there's cheap stuff that's out on the market that doesn't hold up, and then there's some really good stuff that's out there. But there's a different price points. There's the sub 1,000, there's the 1,000 to 2,500, 2,500 to like about 10,000, and then there's like 10,000 up to about 100, and then over 100 all the way up into the $1 million for some of the equipment. But you can envision the different types of things you're doing with this, and the places that it's going. Some of the things that you're looking at is obviously direct metal printing, and there's already some direct metal printers out there. But direct metal printing by layer and using lasers to correct any particular thing on any given layer, or to make modifications to it, and then take it up so that when you take the part off, It's absolutely perfect. And think of bridges going in your dental applications. I mean, that's how it's done today. So because some of the things that you can't do with typical CNC or any other type of way, you would essentially build models before and do inverses of them and do casts off of them. Well, instead of going through that extra step, now you can just direct print. So all the different metal printing that's coming, all the different, like I said, the injectable, and I keep saying injectables, and I meant implantables, all the different resins that we have that we're working with different people out in the community to get those things move forward quickly. Right? Carbon fiber is a big push right now with nylons. You can see that in the racing applications. You can see that on a lot of different things where you really need the strength to do it. But you can take these things and you can do high temps with them. You can take them and do a post-process annealing, and so you can take them up into several hundred degrees C. So
I just pulled up the Lulzbot Taz 6 3D printer on Amazon Prime.
It is funny. I mean, the little mini, is also on there, and there's a big marketplace that just goes right through Amazon. But there's all the, like I said, the resellers, and we direct sell too, and it's the chain to the customer is just as open as the supply chain is.
So you may be new to the company, but you're not new to the industry. You mentioned working with Chuck Hull at 3D Systems. Tell me about your background and what got you to where you are today.
I've been in technology most of my life, and I was with Motorola and went through. I worked in several of different groups and sectors. And back at the time, Motorola was one of the premier telecommunications companies. I mean, all the pagers and the phones, and they built the first cell phones. And but I was with them for a good 10-year run and did things in several of the different groups and sectors. And some of the things that Motorola taught you was they were the inventors of Six Sigma too, and a lot of people don't really realize that. But looking at processes and process control and all these kinds of things, and the education of the employee was a tremendous thing for them. But being in on the cutting edge of all the technology with Motorola really was phenomenal. And I got pirated away. I went to Qualcomm, and I went through Qualcomm's meteoric rise with the phones. And that company went from literally in a very short time frame from a couple $100 million to a couple billion. And we're talking, everybody knows the story, but I mean, the stock just went through the roof, and everybody made a lot of money. But anyway, and from there I got pirated because there was a Motorolan at Qualcomm, and there was Motorolans at 3D Systems, and I got pirated to go to 3D Systems, and I actually started out with them in the European area, and worked in Europe for the first 3 years that I was with 3D Systems, and I was growing the European business and running the European operations. And at the time, 3D Systems was just utilizing stereolithography, which Chuck Hull had brought the industry out with, and we had just introduced the very first of what you would call a 3D printer. But keep in mind, a 3D printer back then, you needed to have a forklift to move it and bring it in. And it had an inkjet head, essentially, that sprayed 256, in a single nozzle. It had 256 orifices in a nozzle that would spray down layer by layer, and there would be a flash, and it would do a photo flash cure of that resin, and you would build these models up. And so, I mean, it was the very, very first of that side of it, and this was, back in the early 2000s, 1998, 99, 2000 timeframe. And then I became the president of 3D Systems, and we went through an acquisition hunt to expand the technology significantly. That was the majority of the reason for the thing. It wasn't to actually to get money out of the acquisitions. It was to grow from a technological standpoint. So bought a company, DTM, Direct to Metal, out of Austin, Texas first, and there was a It was to buy the selective laser sintering, and that was basically a nylon deal. So you're using lasers against nylon to build these parts up. And we were looking at that because we were really looking at additive manufacturing at that time and trying to build for different companies, and I will say in the aerospace industry, building air ducts for airplanes was one of the first things that ever happened from an additive manufacturing standpoint. And I'm sure you can guess who that is, but I'm not going to tell you. But anyway, and then it was to other things, and we actually bought Ciba-Geigy's developmental arm of one of their little resin producer side that was full of PhDs, and we bought them, and so that we could mimic all the different materials that are out there with these photocurable resins. We were trying to get to polycarbonates, trying to get to ABS and things like that. So anyway, we moved forward with some of those acquisitions, and from my perspective, I mean, after a certain time, then I will say we were sued by the Justice Department because their words were, they didn't want us to become the next Microsoft, and they wanted to keep, the 3D printing thing open enough. And so anyway, we fought through that particular thing, got through it, and I took some time off my personal side. I made some money, and then I bought a ranch in northern Wyoming. Took 7 years and had a dude ranch, and had a lot of fun, and then kind of got back into it. And the last company I was with 7 years, and that was Battenfeld, Cincinnati, and it was an extrusion company, and we grew it significantly, tripled the size of the U.S. market, grew the entire company, and then we sold it just about 2 years ago, and so I was on a retainer with them for the last couple of years, and then started talking with Jeff and looking at what they were doing and how they have gotten here. And with this filament approach, to be able to rival the stereolithography parts coming out down to like 25 micron layers, it was just undreamable back just a few years ago, and they're here now. So it's been a great start to my time with them, and like I said, we are looking at 10x growth just over the next few years here.
So what's driving that growth? Is it quicker to make things through additive printing than it is to do direct injection, or what's the driver?
Well, there's two pieces. Yes, I mean, from the prototyping standpoint, it's cheaper, it's quicker. I mean, you can dream something up one day and you can actually be in business selling the parts on Monday or Tuesday, right? I mean, it's that quick, it's that easy, and there's a whole bunch of people out there selling stuff, that are just parts, and selling them through eBay or selling them through Amazon or whatever, and they take your orders and then they print the parts and ship them. But there's also from the manufacturing side of the house, and so it's the two pieces. But from the manufacturing side of the house, if you have some of the small parts and you're going to make literally millions of them, yes, I mean, you can get a tool and you can inject, mold it, and spit them out, and if you're making millions of parts, yes, it's cheaper. If you're making, smaller quantities of the parts and you want to be able to change, you want to be able to not hold any inventory and not have to pay for the tools and things like that, it's cheaper to just print them out. And I think you're getting to the point now where the only thing that's going to rival, the only reason you're going to go to the injectable tools is, just the time, right? So you can actually set these printers up, and I mean, these printers are a cheap capital purchase for what they actually put out, versus, some of the tools. I mean, you could put a few of these out there. So you'll always have that, and your beds are limited and things like that for part size. But there's certain things where if you're building less than $1 million and you don't want to hold inventory, use a printer. I mean, it's getting to that point.
I want to take a quick segue into something that I thought of when you were talking about that. Recently in the news, there was ruckus over 3D printed guns, right? So these are plastic guns, which I assume now they could be made out of non-plastic, whether it's a polymer, whether it's actual metal itself. Has your industry faced any challenges from like a regulatory perspective of?
No, we're not removed from, we're not removed in a certain sense, and you are removed from a certain sense, because we're not actually making those parts, right? We make the equipment that they can make those parts, so we're removed from that standpoint. But I will say, and I'm not concerned about the gun situation. I mean, that'll be handled through legislative type of an approach or whatever they want to do. But when you think about the gun, you better know how to design. You better know how to do things, or you'll have you'll have a problem with your hand anyway. So, but let's focus on something a little bit more, and that is, like I said, the entire parts that you'll be able to print out bones, and there's guys that are looking at how you're going to put DNA in some of your things that you're printing out so that it's accepted in the body quicker, and all that has to be tested and things like that. And so do you do that here in the United States, where you have the whole FDA approach, which is a good thing, but you have a bunch of people who are really pushing the envelope in a lot of these different areas and a lot of different applications. The hearing aids, obviously, you can just print the stuff out and put it into your ear now, right? You melt wax into your ear, you take it out once it's formed, and then you do a little tabletop scanner, scan it, and then you just print it out. I mean, it's very simple. And put the guts of the hearing aid stuff into it, and now you have some of your best hearing aids, rather than behind the ear or something, those that are in the ear cavity itself, they hear the best with. So all of that, all your dental applications, but it's just beginning with the whole human interaction. And so all of those things, yes, I mean, you're going to have some regulatory pieces of it, and obviously the filaments that you're going to put through it, and the contamination of the part during the process and things like that, all of that has to still be worked on, and that's where we will be getting, obviously, having some regulation put on the 3D printer makers, because if you're going to have these going into these industries, it has to be sterile and all that kind of stuff. So there is that kind of thing hitting you, more so than printing a gun out, right?
So you mentioned Czechoslovakia having much more liberal laws and regulations when it comes to this. So if I needed surgery done on my body, I could potentially fly overseas, have the part added to my body, and then come back to the United States and just skirt all that regulatory complexities. Have you seen much of an interest in the medical community overseas in 3D printed products and how to bring those to market?
I will say that the medical community, even in the United States, this is a tremendous market in the United States, because they are, they are actually going through, and as I said, even just with the dog, scanning the head, they actually have scanning equipment out there where they will scan your entire bone structure, your entire body, your facial makeup, everything. They can scan everything, and they do, and then they can actually make all of this stuff, and if you want it, and you can do it very quickly, then you can take that and turn it into, like I said, a cast with, and put it through and actually have implantable materials right away. So, I mean, it'll take you a day to make your parts, a day to cast it, and it's in your body on the third day, right, or the fourth day. I mean, that's how quick it is already today. And I'm just saying the implantables will be there very quickly. So the medical community, and so people who are doing that, rather than flying to some other country to get it done, they can do it here. It's just there's a further processing that happens from the time they start it.
So what does your legal team look like in terms of like size? Because this is really cutting edge stuff that you're talking about, but you've got to know, as the president of this organization, you've got a large body of work in front of you in terms of, administrative and legal matters that you've got to clear. Are you guys prepared to handle that, or how are you prepared to handle that?
Well, again, I want to caution on that, and that is, we provide the tool for them to be able to do that, right? And so a lot of the activity from the legal standpoint is actually going to be the people who are using the equipment to make those particular parts, or to make the or to make the whatever. They will face the scrutiny. We will be scrutinized if we get into the sterile environments and things like that. And today, currently, we're not there. Yes, we will have to approach all of that, and we will have to be, legally compliant in all regards in each one of those. Today, we don't have to face that because today it's just being utilized by other companies, other individuals to move this forward, right?
You guys make the tool, and you don't design the product to be made. You just make the tool. So that's probably a much better place to be in a regulatory environment.
Yes, from a regulatory environment, it is a much better place to be because somebody else is going to do the CAD design that's going to come up with the part that's going to do it. All we do is affect the CAD design to the end part, right? And you take from the CAD design to the end part, what you're looking at is how do you shrink that cycle time down to absolute bare minimum, right? So that's the beauty of being able to use a printer. You can take out all that cycle time. You can literally design a part in CAD. And if it's a small part, you can have it printed in, say an hour, and you're holding it in your hand. I mean, when you walk in the door at Aleph, one of the things that's very interesting is there's about a printer almost on every single desk for every single employee, and all the employees' desks are covered, and you can see their personality coming out because they make all their own parts. And that helps in the development also because people who have no computer knowledge, no CAD knowledge, and no 3D printer knowledge, they're up and running the first day while they're working here, or the second day they're working here, and you're printing out. So like my very first day, put the machine down, open it up, hey, what's the first thing I'm printing? This is really stupid, but what's the first thing I'm printing? I printed out some little hooks to put over my door so you can hang your coat up, right? So I mean, it's just everything under the sun you just print out, and like I said, the personalities on everybody's desk of all the different things. One of the things I will be doing is I'm printing out a couple of things that are going to go on as the tips of my skis, and I'm modifying my pair of German vocals that I've got and putting on some little Celtic skulls with horns and stuff coming out of them, and they'll be the tips of my skis, So anyway, it's just fun things to do with it, but you test the boundary of what you can do with it just right here in the office.
That's true maker culture right there. I like that.
That is true maker culture.
Are you guys in any of the school districts in terms of getting kids educated on additive technologies or design?
Yes, we are. And I will tell you, our largest market to date, is actually the education market. And I think I mentioned that we are a preferred supplier for the Denver Public Schools and the STEM classes that are happening everywhere. We have it in just about, I believe, every county almost in Colorado. We have equipment in. Library sits in there, but back to the education side of it, we have them in universities all over the United States. The Southern California school system we have is only second behind Denver in the amount of printers that we have inside of schools.
I walked in my daughter's middle school library a few weeks ago when school was starting up, and they had I didn't catch the name of the 3D printer, but they had one in the library, and just talking to the librarian about it, she said that they all went through training on how to use this thing, and that they would be rolling that out to students this year. So I think that's really cool stuff.
Yes, it is. It really is cool. And when we ship these things out, it's funny. I mean, the little mini only weighs 18 pounds, right? And so you take it out, and I'm going to say, without having anybody help me inside the company or anything, they dropped off the little box. I took it out. Within an hour, I was printing my first parts. And it's that simple.
Yeah, the easy-to-use aspect of it is critical. If you're going to change the world, you've got to make it easy for people to get involved and quickly get up to speed. They're not going to read a 150-page manual on how to print a coat hook. They're just going to sit down and want to design it and hit print, in essence, right?
That's right. That's right.
Grant, I could talk to you forever about this stuff. I think this technology is so interesting. Just putting the power of creation in somebody's hands, right? You design something on the computer, you hit print, and then a few minutes later, your object comes out. Whether that's something you need around the office, something you need at home, or you're doing prototype, or actually designing something for real use. I think it's really interesting technology, and the scale and the speed that you've hinted at is really amazing. So I can't wait to see great things come from you guys in the future. And I want to thank you for coming on the show today and telling me about this.
Well, Trapper, and again, thank you for having us on the show today. Not just myself, but the entire company. And if anybody is interested, obviously we have a website, alephobjects.com. You can also look up Lulzbot, Lulzbot, and you can look us up online and see all the stuff. And you can also get on Amazon and order. And it's very, very easy, very simple. Just pop on and buy yourself a printer, and within 2 days with Amazon Prime, it's sitting on your tabletop, and within an hour, you're printing a part.
Thanks for listening to this episode of Colorado TechCast. Visit our website at coloradotechcast.com for episode show notes with links to all the great resources we've talked about in this episode. While you're there, click the subscribe button in iTunes so you'll never miss a new episode. I'm Trapper Little, and I'll talk to you again on the next episode of Colorado TechCast.